For this video, we're going to analyze this simple circuit here. We are treating the voltage across the capacitor to be the output voltage, and then we're saying whatever voltage is applied in the left terminals. Pretty much you can think of this as a voltage source connected here, Vn. We are going to use this, we're going to find the transfer function, which is going to be Vout over Vn in terms of phasors. And we're going to analyze this transfer function, and we're going to see that based on the transfer function that this circuit is actually going to be a type of a filter. And it's called a passive filter. We'll explain why that is a little bit later in the video. But this is what we're dealing with here. Now, what we're trying to do is, since we're finding a transfer function that depends on the variable omega, well, that means our omega is a variable. It changes for different values. And so when we change this into phasor notation, we're not going to have a specific number for the impedance of the capacitor. We only can use the formula. It's 1 over j omega c. Now we're trying to find Vout, which is the voltage across the capacitor. And we see that we really just have a voltage divider circuit here. So that means that the Vout is the total voltage, Vn, times the impedance we're at, 1 over j omega c, over the sum of the impedances, R plus 1 over j omega c. So if we divide both sides by the Vn there, then h of j omega, Vout over Vn, is equal to 1 over j omega c over R plus 1 over j omega c. We're going to go ahead and multiply top and bottom by j omega c. And we're going to get 1 over, I'll rearrange the terms here, 1 plus j omega rc. So this right here gives us our transfer function. And we can even write it slightly differently here so that it's in our standard form for graphing Bode plots. This is the same thing as j omega over the reciprocal 1 over rc. So we remember that when we want to graph these things, we first look at our k value. Well, our k is 1 here, the constant on top, and 20 log of 1 is 0. So we know that it has a flat at 0 there. And 1 plus j omega naught, it also starts out flat. My break frequency is 1 over rc. So it's going to start out flat, and then since it's on the denominator, it's going to go downwards. And this becomes our Bode plot. Now you see here, for low frequencies before this value 1 over rc, that's where the high point of my graph is. And after we get past the 1 over rc, it's going to go downwards, making it getting worse and worse output in that case. So what this does is this circuit will allow low frequencies to go through, but high frequencies will get attenuated at lower. So this means this circuit is a low pass filter. So we've just drawn an example of a circuit that is a low pass filter. I will let you check by just doing the calculations again. If we had instead chosen the Vout to be across the resistor, what it would end up being is it would end up being a high pass filter. So you can get low pass filters and high pass filters just by a simple RC circuit here, depending on where you measure your output voltage. Now I promised you I would talk about what passive means. So if we look at this here, our graph on our Bode plot, the highest it ever gets is 0. And since again we know there's 20 log of the magnitude, in order for this output to be 0, that means the magnitude is 1, and that means the output is just going to be equal to the input. So for this filter, the best you'll ever get is when the output is equal to the input. It can never be greater than it. So the gain of output to input is always less than or equal to 1. And that is true for every passive filter. If you ever want to have a gain bigger than 1, where the output is, say, double the input, or 5 times the input, or something else like that, you would need something else in your circuit in order to actually make it have that gain there. And if you think back to what we learned previously, the circuit element that can cause a gain in a circuit is going to be an op amp. So active filters, those are going to be ones that have op amps, and we will see an example of that in the next video. So what I want you to be able to do is, if I give you a circuit here, I want you to be able to find the transfer function, doing your analysis like this, then draw a Bode plot, and then figure out what type of filter you're going to have. You can even cascade these filters. For example, you could have gotten this low pass filter, then you could have used this V out as the input into another circuit, maybe another RC circuit, and had a different filter. Maybe the second one's going to be high pass. So then you could have a low pass and then a high pass, and then essentially nothing would happen, right? Because one of them only allows low frequencies through, one only allows high frequencies through, and at the end of the day, nothing would get through. But you can also play around with the exact numbers here, and you can get more complicated filters by cascading them this way. But for right now, we're just doing simple basic circuits here so we can get the idea of how a filter works.